Hello students, welcome back to the study of Biomolecules chapter. We'll have just recap of our previous class. We are dealing with the study of carbohydrate biomolecules. In previous class, we have discussed what are monosaccharides, classification of monosaccharides into aldoses and ketoses, classification of monosaccharides based on number of carbon atoms into trioses, tetroses, pentoses and hexoses. Later we have discussed first monosaccharide glucose, its preparation. Then later we have discussed an important concept of structure elucidation. Based on some evidences, we have proposed an open chain structure for the glucose molecule, and the structure is like this, isn't it? Okay, well, and we have named this open chain structure as a D plus glucose, where capital D indicates the configuration of a glucose molecule and plus indicates its dextrorotatory nature. So this concept we have discussed in a previous class, isn't it? Okay, and I have said you one point in the previous video that the open chain structure of glucose has many drawbacks, failures, isn't it? So that we will discuss in the next class anta ಹೇಳಿದ್ದೆ. Okay, so let me begin with today's class. This open chain structure, whatever the structure you see in the screen, this open chain structure explained most of its properties. Okay, but there are some exceptional cases. We'll see what are those exceptional cases. First of all, this glucose does not give Skiff's test. A molecule of glucose fails to give Skiff's test. Skiff's test is a qualitative test of aldehyde functional group. We know that glucose contain aldehyde functional group, no. So hagadre it should have given Skiff's test positive, but glucose molecule fails to give Skiff's test. This is the first failure, exceptional case. Second one, this glucose does not form hydrogen sulfide addition product with NaHSO3. Here you make some correction. It is printed as NaHCO3. It's not NaHCO3. Okay, so this is NaHSO3. NaHSO3 is hydrogen sulfide. Please make correction in the notes. Okay, and this reaction also, addition reaction of a carbonyl group, aldehyde group with a hydrogen sulfide. So to give hydrogen sulfide is also a test for a aldehydic group. That test is not given by which open chain structure. And glucose, actually glucose, latest study shows that glucose is found to exist in two forms. They are alpha form and beta form. But the open chain structure did not explain anything about these two forms, alpha form as well as a beta form. So these were some exceptional cases, drawbacks or failures of a open chain structure. Later studies shows that, okay, so look here, these behaviors could not explained by the open chain structure of glucose. Why? Because the later studies shows that the glucose forms a six-membered ring. So far we have discussed open chain structure, a straight structure of a six-membered carbon atoms, no open chain structure. But later studies found that glucose molecule has a six-membered ring in which OH of a carbon number 5 is involved in a ring formation. So because of this, there is absence of a CHO group. Aldehyde group is not there. This aldehyde group is involved in a ring formation, and also it explains the existence of a two forms. We'll see what's that structure. Okay, you can see three structures on the screen. This middle structure is an open chain structure that we have discussed. Okay, so here what happens is this carbon number 5, the OH group present at a carbon number 5 makes a ring with a carbon number 1. Carbon number 1 is an aldehyde group. So there is a ring formation between carbon number 5 and carbon number 1. Therefore, we'll get this structure. So ಈ structure ನೋಡಿ, here you see this carbon number 1 links with the carbon number 5 through this bond, through oxygen atom, isn't it? Andre, it's a 6-membered ring structure. Okay, so latest study shows that glucose is not found to exist in this form. It is found to exist in this kind of a ring structure. Okay, these structures are called Fischer structure. So we have two types of structures here. So can you see this structure and this structure? What's the difference between these two? So the position of H and OH at a carbon number 1. So look here, in this molecule, the hydroxyl group is present on the right side, whereas in this molecule, hydroxyl group is present on the left side. So these are the differences between these two forms, and this form is called alpha D plus glucose, whereas this form is called beta D plus glucose. Okay, and these two structure, this structure and this structure, explains those exceptional cases. This molecule does not give Skiff's test. Why? Because there is no free aldehyde. The aldehyde group is involved in what? It is involved in a ring formation. Therefore, does not give Skiff's test, does not give additional products with the hydrogen sulfide, and the glucose is found to exist in a two forms, alpha form and beta form. Okay, so these are ring structures. As far as your annual examination is concerned, this open chain structure as well as these two ring structure that you are seeing on the screen, no, will not be asked for an examination. Each structure na bariri, write this open chain structure, this Fischer structure for 1 mark, 2 mark anta prashne kelodilla. So we'll have a very important concept, another structure that's called as a Haworth structure. That structure is important for examination point of view. Is that clear? ಈಗ ಕಾಣಿಸ್ತಾ ಇರೋ ಸ್ಟ್ರಕ್ಚರು ಬರೀರಿ ಅಂತ ಎಕ್ಸಾಮ್ದಲ್ಲಿ ಕೇಳೋದಿಲ್ಲ. ಬಟ್ these structures are important for competitive examination point is concerned. Okay, we'll move to the next structure. It's called Haworth structure of glucose. I'll repeat, very important for examination point of view, board examination point of view. And one more thing, if you know how to write a molecule of a Haworth structure of a glucose, you can write structure of fructose, you can write structure of maltose, sucrose, lactose, starch, glycogen, etc. That means it's a basis. So ಇದೊಂದು ಬರೆಯೋದು ಹೆಂಗೆ ಅನ್ನೋದು ಗೊತ್ತಾಯ್ತು, ಮುಂದಿನ ಎಲ್ಲ ಸ್ಟ್ರಕ್ಚರ್ ಬರೆಯೋದು ಈಸಿ ಆಗ್ತದೆ. ಎಲ್ಲ Haworth structure ಏನು ಎಕ್ಸಾಮ್ಗೆ ಇಂಪಾರ್ಟೆಂಟ್. ವಿಲ್ ಸಿ Haworth structure. It is also a 6-membered ring structure, isn't it? ಕಾಣಿಸ್ತದಾ? So it's a 6-membered ring structure. So one member is oxygen. Can you see? Make out this point, red point in the ಕಾಣಿಸ್ತಾ ಇದೆ ಇದು. This is oxygen. Whereas this one is carbon. Second member carbon, carbon, carbon. So out of 6 atoms in the ring, one member is oxygen and remaining 5 members are carbon atoms. So it's a 6-membered ring. So this is carbon number 1, 2, 3, 4, 5 and CH2OH group is there. No, this carbon is 6th carbon, and this carbon is called alpha D plus glucose, and this is called beta D plus glucose. Again, this alpha and beta are differ at the position of H and OH at a carbon number 1, isn't it? Look here. So in alpha form, HOH is like this. Beta form allenide OHH. So here alpha form OH is below the plane, whereas here it is above. So that's the only difference between these two forms. And you can see there is one word. This structure is also called alpha D plus glucopyranose. This is called beta D plus glucopyranose. Why it is called as pyranose? That is due to this structure. So we have one organic compound, a heterocyclic compound. ಈ ರೀತಿ ಇದೆ heterocyclic compound, a 6-membered compound. This compound name is pyran. It's a organic compound, heterocyclic compound. ಇದರ ಹೆಸರೇನು? pyran ಅಂತ. Okay, pyran. And this pyran structure is present here, no? So it looks like a pyran structure, 6-membered ring, where 1 member oxygen and remaining 5 are carbon, no? So since it looks like a pyran, this is also called as what? Pyranose. Alpha D plus glucose andrunu ಒಂದೇ, alpha D plus glucopyranose andrunu ಒಂದೇ. Okay, so now I'll tell you how to write this structure. I said, this structure is very important. ಹೆಂಗೆ ಬರೆಯೋದು? ಈಗ ಆಲ್ರೆಡಿ ನಾನು ಬರೆದಿದ್ದನ್ನ ಸ್ಕ್ರೀನ್ ಮೇಲೆ ತೋರಿಸ್ತಾ ಇದ್ದೀನಿ. So you follow this technique while writing the structure. So ಏನು part technique ಅಂತಂದ್ರೆ, you follow this pattern. It's not actually technique, pattern. ಅಂದರೆ ಫಸ್ಟ್ we need to write a HOH carbon atom ring ಬರಿಬೇಕಾ? ಅದಕ್ಕೆ ಒಂದು ಪ್ಯಾಟರ್ನ್ ಫಾಲೋ ಮಾಡ್ರಿ, so that the same pattern we can follow in a next structures also. First draw a 6-membered ring structure. 1 member is oxygen and remaining 5 members are carbon atoms. Okay, so first draw this ring structure. Now we'll write the positions of H and OH. Okay, so follow this pattern. So andre nimge ನೆನಪಿರ್ತದೆ, this is carbon number 1, this is carbon number 2, this one is carbon 3rd, 4th, this is 5th carbon, and here we'll get a 6th carbon. I'll write that 6th carbon. So ಏನು ಪ್ಯಾಟರ್ನ್ ಫಾಲೋ ಮಾಡಬೇಕಂದ್ರೆ, ಫಸ್ಟ್ ವಿಲ್ ರೈಟ್ ಪೊಸಿಷನ್ಸ್ ಆಫ್ H and OH at ಕಾರ್ಬನ್ ನಂಬರ್ 1. ಒಮ್ಮೆಕ್ಲಿ ನೀವು 6th ಬರೆಯೋದು 4th ಬರೆಯೋದು ಮಾಡೋಕೋಬೇಡ್ರಿ, ಈ ಪ್ಯಾಟರ್ನ ಫಾಲೋ ಮಾಡಿರಿ. ಸೊ 1ನಲ್ಲಿ ಏನು ಬರೆಯೋದು? H, OH, ಸೆಕೆಂಡ್ ಕಾರ್ಬನ್ H, OH, third carbon OH, H, fourth carbon H, OH, and here CS2, OH and H. So you need to follow this pattern. ಅಂದರೆ ನಿಮಗೆ ನೆನಪಿಡ್ಲಿಕ್ಕೆ ಈಸಿ ಅನ್ನಿಸ್ತದೆ. ಸೊ ಏನು ನೆನಪಿಡಬೇಕು? Positions of H and OH. So to draw the 6-membered ring is very simple, no? With oxygen atom, one of the member. But writing of these positions are very important. If you make a very slight mistake, so H ಬರೆಯೋದ್ರಲ್ಲಿ OH ಬರೆದ್ಬಿಟ್ಟೆ ಉಳಿದಿದ್ದೆಲ್ಲ ಸರಿ ಇದ್ರೆ, you will get a 0 mark. This question will be asked for 2 mark. Okay, ಅದಕ್ಕೆ ಇಂಪಾರ್ಟೆಂಟ್. ಒಂದು ಸ್ವಲ್ಪ ಮಿಸ್ಟೇಕ್ ಆಯಿತು, will not get a 1 mark also. ಕೊಟ್ಟರೆ 2, ಇಲ್ಲಾಂದರೆ 0. ಅದಕ್ಕೆ ಡೋಂಟ್ ಮೇಕ್ ಮಿಸ್ಟೇಕ್ ಹಿಯರ್. ಸೊ ಏನು ನೆನ್ಪಿಟ್ಕೋಬೇಕು? H, OH, H, OH, OH, H, H, OH, then CS2OH, H. So if you follow this, it's a very simple to write a Haworth structure of alpha D plus glucose. So here I have written alpha D plus glucose. Then what about beta D plus glucose? It's a simple. So instead of HOH at carbon number 1, so we'll have OH and H. So that's a beta form. Okay, will you write this structure? Yes. Now the same thing. So na ಹೆಂಗೆ ಬರೆಯೋದು ಅಂತ ತೋರಿಸಿದೆ, ಇಲ್ಲಿ ಆಲ್ರೆಡಿ ಬರೆದಿದ್ದಿದೆ. ಸೊ ಕ್ಯಾನ್ ಯು ಸಿ H, OH, H, OH, OH, H, H, OH, then CS2OH, H. So beta formದಲ್ಲಿ only the position at carbon number 1 will be different. So this is about the Haworth structure of glucose, very very important for 2 marks. And these two cyclic forms of glucose, they differ in the configuration of hydroxyl group, OH group at carbon number 1, called as anomeric carbon. So this form and this form both will differ at a position of this OH group at carbon number 1. And this carbon number 1 is called as what? Anomeric carbon. Meaning is it is the aldehyde carbon before cyclization. This one, carbon number 1, and here this carbon is called anomeric carbon. And such isomers, these two isomers are called alpha form and beta form. They are called as what? Anomers. Okay, what are anomers? But you remember what are ionomers? The two forms here, for example, of a glucose molecule which differ in the positions of hydroxyl group at a anomeric carbon, that is carbon number 1. Clear? Okay, so you need to make practice of writing this Haworth structure of glucose. Okay, I have said you in the first class itself, make a separate notebook for my class. You need to take down all my ನೋಟ್ಸ್ ಅಂತ ಹೇಳಿದ್ದೇನೆ, ಹೌದಿಲ್ಲ? ಸೊ ಇದನ್ನು ನೀಟಾಗಿ ಬರ್ಕೊಡ್ರಿ. ಹೆಂಗೆ ಬರೆಯೋದು ಅನ್ನೋದು ನಾನು ಆಗಲೇ ತೋರಿಸಿದ್ರಿ ನಿಮಗೆ. ಅದೇ ಪ್ಯಾಟರ್ನ ಫಾಲೋ ಮಾಡಿರಿ. ಸೊ ಒಂದು ಬಿಟ್ಟು 2-3 ಸರಿ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿರಿ, ಬಿಕಾಸ್ ಇಟ್ಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಈ ಸ್ಟ್ರಕ್ಚರ್ ಗೊತ್ತಾಯಿತು, ಮುಂದಿಂದೆಲ್ಲ ಸ್ಟ್ರಕ್ಚರ್ ನಿಮಗೆ ಬರೀಲಿಕ್ಕೆ ಈಸಿ ಆಗ್ತದೆ. These 6-membered cyclic structures are called pyranose structure. Why? I have said you already, and it is important for how many mark? 2 mark. Okay, clear. Well, in July 2014 annual examination, so there was one question in the annual examination question paper, 36th A question. Write a Haworth structure for alpha D plus glucose. For how many mark? 2 mark. Heng bariyodu? Just now I have explained, you know, write like that. Okay, on the rangoli tegeyodu. See here, first draw the 6-membered ring. Then positions, come on, ಹೇಳ್ತಾ ಹೋಗಿ 1 2 3 4 5 ಗೆ. ಸೊ ಹೇಳ್ತಾ ಬರಿಬೇಕು. Carbon number 1, come on, HOH, isn't it? Yes, HOH. Second carbon, HOH. Third carbon, OH, H. Fourth carbon, HOH. And fifth carbon, CH2OH, H. If you write like this, you'll get a 2 mark. So very simple, no? I'll repeat. ಸೊ 2 ಮಾರ್ಕಿಗೆ ಕೇಳ್ತಾರೆ, ಕರೆಕ್ಟಾಗಿ ಬರೆದ್ರೆ 2 ಮಾರ್ಕು, ಸ್ವಲ್ಪ ಮಿಸ್ಟೇಕ್ ಆಯಿತು 0 ಮಾರ್ಕ್, 1 ಮಾರ್ಕ್ ಅಂತೂ ಸಿಗೋದೇ ಇಲ್ಲ. ಸೊ ದಟ್ ಬಿಕಾಸ್ ಆಫ್ ದಟ್ ಯು ಮೇಕ್ ಅ ಪ್ರಾಕ್ಟೀಸ್ ಆಫ್ ರೈಟಿಂಗ್ ದೀಸ್ Haworth structures. We'll move to the next next monosaccharide, fructose. Fructose is again a simple monosaccharide called as a ketohexose. So this ketohexose word has two words, two parts. Keto refers to presence of a ketonic group. Hexose refers to a monosaccharide containing 6 carbon atoms, isn't it? Okay, and this fructose monosaccharide is found in honey, wine fruits, flowers and berries of most of root vegetables. This fructose also has the molecular formula C6H12O6. Glucose uddu eno? C6H12O6. Okay, so some students were asking, sir, glucose and fructose have the same molecular formula, whether their structures are same anta kelta idri. Hauda? Structure is entirely different, but their molecular formula is same. We'll see the structure now. This open chain structure of fructose contain a ketonic group where at the carbon number 2 and a 6 carbon atoms in a straight chain. So look here, this is open chain structure of glucose. 6 carbon atoms are present in a straight chain. There is a carbonyl group, C double bond O group at the carbon number 2. Okay, and this is called D minus fructose. Here capital D represents what? Capital D represents configuration. So this bracket ಅಲ್ಲಿ minus ಏನು indicate ಮಾಡ್ತದೆ? It indicates that it is levorotatory compound. Glucose is dextrorotatory, whereas fructose is a levorotatory compound. See here, levorotatory compound ಇದು. Okay, that means it rotates the plane of polarized light in a anti-clockwise direction. Okay, fine. We'll see next concept. So this fructose also exists in 2 cyclic forms. Okay, this one is open chain form. This is open chain form. So it also exists in 2 cyclic forms. So we are not studying in detail about fructose. Structure elucidation concept is not there. So this is closed structure, ring structure of a fructose. Not important for examination. Exam ge kelodilla. Don't worry about this. But it is important. This one, Haworth structure of a fructose, which is a 5-membered ring. Glucose, our structure was a 6-membered ring, whereas this one is a 5-membered ring. Okay, structure ಬೇರೆ ಇದೆ ಹೌದಿಲ್ಲ ಗ್ಲೂಕೋಸ್ಗೆ ಇದಕ್ಕೆ, but molecular formula is same. So this is alpha D plus fructose, and this one beta D, sorry, this is called alpha D minus fructose, and this is beta D minus fructose or fructofuranose nu anತಾರೆ. Why that word furanose? We have one again heterocyclic compound. The structure of heterocyclic compound is like this, which is a 5-membered ring. One member is oxygen. Its name is furan. It's a heterocyclic organic compound. Idra ಹೆಸರೇನು furan andage. Okay, so since that the structure of a fructose looks like this furan structure, no, hence it is called fructofuranose or fructose, which is a levorotatory compound. Okay, so here positions nodi. This is carbon number 1 CH2OH, carbon number 2 OH, CH2OH OH, OH H, HOH, CH2OH H. So beta form is different from alpha form, where the position of OH at a carbon number 2. Here CH2OH OH is there, whereas here OH and CH2OH is there. Okay, practice these structures, important for 2 mark. So far we have discussed 2 monosaccharides, glucose as well as fructose. Let us continue our study with the disaccharides. You know, disaccharides are the carbohydrate which gives 2 monosaccharide units upon hydrolysis. This concept you know. And these 2 monosaccharides are joined together by one linkage called as what? Oxide linkage. It's also called glycosidic linkage by the loss of water molecule. We'll see structurally ನೋಡೋಣ. First disaccharide is sucrose. It's one of the important useful disaccharide in our daily life, distributed in nature in juices, mainly in sugar cane juice, seeds of some plants, fruits, and also in the flowers of many plants. The main source of sucrose is sugar cane juice. Okay, table sugar ಅಂತ ಹೇಳ್ತಾರಲ್ಲ, ನಾವು ಮನೆಯಲ್ಲಿ ಯೂಸ್ ಮಾಡೋ ಸಕ್ಕರೆ ಏನೋ, it is sucrose obtained from a sugar cane juice. ಕಬ್ಬಿನ ಹಾಲು, sugar cane is ಕಬ್ಬು, ಹೌದಾ? This sucrose upon hydrolysis produces equimolar mixture of glucose and fructose. This equation we have discussed already. C12H22O11 is sucrose. Upon hydrolysis in acidic media gives D plus glucose and D minus fructose. This structure reaction we have discussed. Haworth structure. So it's a disaccharide, no? Sucrose is a disaccharide which is composed of one alpha D plus glucose and another one beta D minus fructose. Then how to write Haworth structure? These 2 monosaccharides are held together by a linkage bond called as a glycosidic linkage or glycosidic bond, where it is present between C1 of alpha glucose and C2 of beta fructose. Look here, this structure dalli what I have written 2 monosaccharide alpha D plus glucose and beta D minus fructose side by side, side by side ಬರೆಯೋದು. You need to write in such a way that the carbon number 1, so red mark ಕಾಣಿಸ್ತಾ ಇದೆ, this carbon number 1 must carbon number 1 of glucose and carbon number 2 of fructose lie side by side. So just ನೋಡಿ, in a previous fructose structure I have shown ಅಥವಾ I have written the structure in such a way that the carbon number 2 was here and carbon number 5 was here. ಹೌದಾ? ಉಲ್ಟಾ ಬರ್ದಿದ್ದೆ ನಾನು. ಕಾರ್ಬನ್ ನಂಬರ್ 2 ಇಲ್ಲಿ ಬಂದಿದೆ, ಈಗ ಆಗಲೇ ನಾವು ಬರ್ಸಿದ್ದು ಕಾರ್ಬನ್ ನಂಬರ್ 2 ಇಲ್ಲಿ ಬಂದಿತ್ತು. ಈ ರೀತಿ ಉಲ್ಟಾ ಬರಿಬಹುದು. ಸೊ ಆ ರೀತಿ ಬರೆದಾಗ ದ ಪೊಸಿಷನ್ಸ್ ವಿಲ್ ಬಿ ಇನ್ವರ್ಟೆಡ್. ಓಕೆ, ನಾವು this carbon number 1 of glucose joins with the carbon number 2 of fructose. Okay, so ಇಲ್ಲಿ HOH ಇತ್ತು, ಇಲ್ಲಿ CH2OH OH ಇತ್ತು, OH ಅಲ್ಲಿ H2O ಹೋಗಿ, so we'll get this kind of a link. So this carbon links with this carbon through this oxygen. So this link is called glycosidic linkage or ಗ್ಲೈಕೋಸೈಡಿಕ್ ಬಾಂಡ್ ಅಂತ ಹೇಳ್ತೇವೆ. ಸೊ ನಾವ್ ಇಟ್ ವಿಲ್ ಬಿ ಸ್ಟ್ರಕ್ಚರ್ ಆಫ್ ಅ ಸುಕ್ರೋಸ್. ಇಂಪಾರ್ಟೆಂಟ್ ಫಾರ್ 2 ಮಾರ್ಕ್. ಏನು ಬರೀತೀರಿ? alpha D plus glucose and beta D minus fructose. Show the link between carbon 1 and carbon number 2. So one more concept we'll discuss here. Sucrose is levorotatory. Sorry. Make a correction. Sucrose is a dextrorotatory. That means rotate the plane of polarized light in a clockwise direction, plus direction, positive direction. But after hydrolysis gives dextrorotatory glucose and levorotatory fructose. This you know. Glucose is dextrorotatory, fructose is levorotatory ಅಂತ ಗೊತ್ತು ನಿಮಗೆ. Since the specific rotation, what is specific rotation? It is the unit of optical activity. Okay, optical activity is measured in the form of a specific rotation. Okay, and it's that specific rotation is angle of rotation by the molecule. Angle of rotation of a light by the molecule. Okay. When upon hydrolysis it produces dextrorotatory glucose and levorotatory fructose. Since the specific rotation of a levorotatory fructose, which is minus 92.4 degree, is more than the dextrorotatory glucose plus 52.5 degree. So now look here, this is minus 92.4 is specific rotation of fructose, plus 52.5 is specific rotation of glucose. Which value is more? Which value is higher? Minus 92.4 or plus 52.5? And one thing, don't look at the sign. Minus sign indicates levorotatory, plus sign indicates dextrorotatory. Sign bitri. 92.4 value just 52.5 value. Definitely 92.4 value is higher, no? Its value, specific rotation, is higher than the dextrorotatory. Therefore, after hydrolysis, dextrorotatory glucose becomes levorotatory. ಮೊದಲೇನಿತ್ತು ಗ್ಲುಕೋಸು ಡೆಕ್ಸ್ಟ್ರೋರೊಟೇಟರಿ ಇತ್ತು, ಬಟ್ ಇಟ್ ಬಿಕಮ್ಸ್ levorotatory. ಯಾವಾಗ? ಆಫ್ಟರ್ ಹೈಡ್ರೋಲೈಸಿಸ್. ವೈ? ಬಿಕಾಸ್ ಆಫ್ ಅ more value of specific rotation of a levorotatory fructose. This change in the sign of rotation from dextro to levo is called as what? Inversion of sugar or inversion of cane sugar anta ಹೇಳ್ತೇವೆ. So it may be asked for 2 mark. What is inversion of sugar? The change in the rotation of a sucrose from dextrorotatory into levorotatory upon hydrolysis is called inversion of sugar. Okay, so sucrose ದಲ್ಲಿ ಈ 2 ಪಾಯಿಂಟ್ ಇಂಪಾರ್ಟೆಂಟ್. ಒನ್ ಈಸ್ Haworth structure and another point is inversion of sugar or inversion of cane sugar. Okay, there was one question in AIPMT competitive examination in the year 2012. AIPMT is All India Pre-Medical Test. Now this examination is called as a NEET examination. Okay, NEET exam ಗೆ ಹಿಂದೆ ಏನಂತ ಹೇಳ್ತಿದ್ರು? AIPMT ಅಂತ ಹೇಳ್ತಿದ್ರು. ಅಂದ್ರೆ it's a NEET examination question. Which of the following sets of monosaccharide forms sucrose? Option number 1, alpha D glucopyranose and alpha D glucopyranose. Option 2, alpha D glucopyranose and beta D fructofuranose. Third option, beta D glucopyranose and alpha D fructofuranose. And fourth one, alpha D glucopyranose and beta D fructofuranose. Okay, among these 4 sets, which forms sets of monosaccharide, which forms sucrose? Okay, ಈಗ ಆನ್ಸರ್ ಹೇಳೋದಿಲ್ಲ. You go through the reaction very carefully, question very carefully, then you answer in the comment box of Google Classroom app. Okay, so ನೀವು ಕಮೆಂಟಲ್ಲಿ ಈ ಕ್ವಶನ್ಗೆ ಆನ್ಸರ್ನ ನೀವೇ ಹೇಳಬೇಕು. ನೆಕ್ಸ್ಟ್ ಒನ್, Second disaccharide, maltose. Maltose is commonly called as malt sugar. It's a reducing sugar. Reducing sugars are the carbohydrate which reduce tolerance reagent and Felling's solution. Maltose is composed of 2 alpha D plus glucose units, in which C1 of one glucose linked to C1 of another glucose. Sucrose composed of what? Alpha D plus glucose and beta D minus fructose, whereas maltose contain alpha D plus glucose and alpha D plus glucose, 2 alpha D plus glucose unit at a C1C4 glycosidic linkage. The Haworth structure is very simple. Look here. In Madidarile, one alpha D plus glucose is written side by side, another alpha D plus glucose. Okay, so carbon number 1 of one glucose links with carbon number 4 of another glucose through this link. This link is called as what? Glycosidic link. Present between C1 and C4. No, ಅದಕ್ಕೆ C1 C4 glycosidic linkage. Very much important for how many mark? 2 mark. Okay, I'll show you how to write this. ಆಗಲೇ ಮೊನೋಸ್ಯಾಕ್ರೈಡ್ ತೋರಿಸಿದೆ, ಈಗ ಡೈಸ್ಯಾಕ್ರೈಡ್ ಹೆಂಗೆ ಬರೆಯೋದು ತೋರಿಸ್ತೇನೆ ನೋಡಿ. Yes, first you need to write 2 alpha D plus glucose units, isn't it? Okay. It's very difficult to draw the structure on this mobile screen. I'll try my level best to draw these structures. Okay, alpha D plus glucose. Come on, tell me the positions of H and OH for alpha D plus. Agle hididnella. Come on. Before that, we'll number. This is carbon number 1. This is carbon number 2. This is carbon 2. Okay. I'll write once again. This is carbon number 2. This is third carbon. Here we have a fourth carbon. This one is fifth and sixth is here. Okay. Positions of H and OH. Come on. You follow that pattern. Carbon number 1, H, OH. Here carbon number 2, H, OH. Here OH, H, H, OH. And here CH2, OH and H. Okay, so I tried my level best on a mobile screen. Next, this is alpha D plus glucose. What I have to draw? Another alpha D plus glucose, isn't it? Yes, a 6-membered ring. Come on, numbering. First carbon, second, third carbon here. This is fourth. Here is a fifth and sixth will be here. Sixth will be here. Now, positions. Carbon number 1, alpha D plus glucose. H, OH, H, OH, OH, H, H, OH, and here CH2OH, H, isn't it? I have written 2 alpha D plus glucose. Is it maltose? No. Carbon number 1 of one glucose links with carbon number 4 of another glucose by the loss of water molecules. Okay, I'll show now. Yes. So here OH are there, no? So here OH and here also OH. Now there will be loss of water molecule. Ill water molecule hogtade. H2O is lost. What is left? Only oxygen is left, no? Okay. Now this carbon links with this carbon through oxygen atom. through this oxygen atom. Now this is the structure of maltose, and this one is what? Glycosidic linkage, glycosidic bond. So ಈ ರೀತಿ ಬರಿಬೇಕು ಅಲ್ರಿ. ಇದೆ what you call clear structure ಇದೆ, but how to draw, how to write the structure, just now I have said you. So ಈ ರೀತಿ ನೀವು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ತೀರಿ, very important for 2 mark. Yes, we'll move to the next concept. Yes, that's a question paper question. March 2014 annual examination question paper 36th A question was like this: write the structure of maltose for 2 mark. July 2014 36th B question: write Haworth structure of maltose 2 mark. March 2015 Haworth structure of maltose. July 2016 same question. March 2017 same question. July 2018, March 2019, July 2019. Look here, so many times this Haworth structure of maltose was asked for how many mark? 2 mark. So ಈ explain ಮಾಡಿದಾಗೆ ನೀವು ಬರಿಬೇಕು. So your answer must be this structure, isn't it? So very simple structure asked many times in the annual examination. I hope it's clear to you. So now your job is to what? Write the notes in the notebook. After that practice these structures. And that's how you practice ಮಾಡಿ ಆಮೇಲೆ try to write the structure without seeing the notes. Then it will be you'll be thorough with the structure. Okay, ಅವಾಗ ನಿಮಗೆ ಕಾನ್ಫಿಡೆನ್ಸ್ ಬರ್ತದೆ. Important. We'll see last disaccharide, lactose. Lactose is commonly called milk sugar since it is found in milk. This disaccharide composed of 2 monosaccharide units. They are beta D plus galactose and beta D plus glucose. Just recall your memory. Sucrose, alpha D plus glucose, beta D minus fructose. Maltose, alpha D plus glucose, alpha D plus glucose. Whereas lactose composed of beta D plus galactose and beta D plus glucose. Where is the glycosidic linkage? Carbon number 1 of galactose links with carbon number 4 of glucose. Then how to write a Haworth structure? So ಏನು ಮಾಡಬೇಕೀಗ? ಒಂದು galactose structure ಬರಬೇಕು, ಬಾಜು glucose structure. ಯಾವ್ದು galactose? beta D galactose. ಯಾವ್ದು glucose? beta D glucose. So link carbon 1 and carbon number 4. You'll get this structure, Haworth structure of lactose. What is galactose structure? A question arises now because you have not learnt galactose before this class, isn't it? Okay, galactose structure will be like this. I'll show you galactose. The galactose structure is very much similar to the glucose structure. First I will write glucose structure. Beta D plus glucose. Come on, tell me the position. Not alpha, beta. Alpha ittandre carbon number 1 HOH bartittu. I am writing beta. It's not HOH. It is OHH. Here HOH would be the position same. OH, H, H, OH. And here CS2 OH H. What I have written? I have written beta D plus glucose. OHH is nodi. It's a beta D plus glucose structure I have written. What is galactose then? I said you beta glucose is very much similar to beta galactose, very much similar to the beta glucose, except the positions of H and OH at carbon number 4. Carbon number 1, this is second, third, fourth, fifth and sixth. So in glucose we have HOH, but in galactose we have OHH. That is the difference. Got it? So glucose dalli HOH irtade, adre galactose dalli ಏನು ಇರ್ತದೆ? OHH, where at carbon number 4. Clear? This is galactose. Now we will come back to our lactose structure. See here, this is galactose, beta D galactose. ಇಲ್ಲಿ OH ಇತ್ತು, ಅದು ಲಿಂಕ್ ಆಗಿದೆ. OH, H, H, OH, OH, H, OHH, this is beta galactose. This is beta glucose. OHH, HOH, OHH, HOH. ಇಲ್ಲಿ ಕೆಳಗಡೆ OH ಇತ್ತು ಲಿಂಕ್ ಆಗಿದೆ. CH2OHH. So these two linked at carbon number 1 and 4. So this is the structure of lactose. I'll show you how to write this lactose structure. ಹೆಂಗೆ ಬರೆಯೋದು ತೋರಿಸ್ತೇನೆ ನೋಡಿ. First I will write galactose structure now. 6-membered ring. I am writing beta galactose. Come on, tell me the positions. Beta D galactose, OH, H, H, OH, OH, H, galactose. Galactose andre OH, galactose, OH, here H, CH2OH, H. I have written galactose. Now side ge ಏನು ಬರೆಯೋಣ beta D plus glucose. Come on, beta D plus glucose. Positions ಹೇಳ್ರಿ. Beta D plus glucose, OH, H, H, OH, OH, H, H, OH, and here CH2OH, H. So number the carbon 1, this is 2, 3, 4, 5, and here 6. This one 1, 2, 3, 4, 5, and here 6. Now carbon number 1 of galactose links with carbon number 4. Now there will be loss of water molecule. ಎಲ್ಲಿ water molecule loss ಆಗ್ತದೆ ನೋಡಿ. Here OH group, ಇಲ್ಲೊಂದು ಕೆಳಗಡೆ OH group ಇದೆ. So water molecule loss will show like this. This will be lost. So can you see that green color marking? H2O is lost. When the H2O is lost, what is left? Only O is left, no? Now structure will be like this. Structure will be like this. There is an oxygen atom links to this. So carbon number 1 of galactose links with carbon number 4 of beta D. This is galactose structure. So ಇದು ಹೆಂಗೆ ಬರೆಯೋದು ಅಂತ ತೋರಿಸಿದೆ. Same clear structure. Look here. Same thing now. Okay. Important for 2 marks. Practice ಮಾಡ್ರಿ. Practice ಮಾಡಿದ್ರೆ ಬಹಳ ಸಿಂಪಲ್ ಆಗ್ತದೆ. Okay. Question paper question 2015 July 36th. A question in the annual examination. Write the structure of lactose, 2 mark. March 2016 same question. July 2017 same question. Even March 2018 write the Haworth structure of lactose for 2 mark. Your answer must be this one. Hold on, just now I have explained you how to write Haworth structure of lactose molecule. So practice ಮಾಡ್ತಿರಲ್ಲ. Yes. One competitive examination question. It's a JEE mains 2009 question. The 2 functional groups present in a typical carbohydrate are, first option, OH and COOH, CHO and COOH, C double bond O and OH, and fourth option is OH and CHO. Which is the right one? In a typical carbohydrate, which 2 functional groups are there? Option 1 ಏನಿದೆ? OH hydroxy group, COOH carboxylic acid. Option 2 aldehyde group, carboxylic acid. Option 3 carbonyl group and hydroxy group. Option 4 OH group, hydroxy group and aldehyde group. Okay, again it's a assignment work for you. You need to find the correct option and write it on a comment box. Okay, so that means I have given 2 questions for your work. So today's concept is Haworth structure of glucose, isn't it? Then disaccharides, sucrose, maltose, lactose, and their Haworth structure. What is left in this carbohydrate concept is polysaccharides. We'll learn 3 polysaccharides in the next class. Thank you very much.